So theorem number 5 tells us that whenever we see a quadrilateral being drawn inside a circle and all 4 vertices are on the circumference of the circle, this is known as a cyclic quadrilateral. And the key thing about cyclic quadrilateral is that opposite angles in a cyclic quadrilateral, they sum to 180. So on the diagram on the left, we see that x plus w, those are opposite angles, that's 180, and y plus z, that's 180. On the right, p plus q is 180, and r plus s is 180. So opposite angles in a cyclic quadrilateral are supplementary, or we say they sum to 180. Now notice, if you're given a quadrilateral right here inside the circle, but all 4 points do not touch the circle, meaning the vertices of the quadrilateral do not touch the circumference of the circle, then it is not a cyclic quadrilateral. So in this case, x plus w is not 180 and y plus z is not 180. Alright? So now let's use cyclic quadrilateral theorem to find the missing angles in these two diagrams. Pause the video and attempt. So on the left hand side, opposite angles in a cyclic quad sum to 180, so x plus 85 is 180. And so x is 180 minus 85, which is 95 degrees. Likewise, 110 plus y is 180. So y is 180 minus 110, which is 70 degrees. That's because opposite angles in a cyclic quad sum to 180. Let's go to the right. Now to find angle P first, because angles on a straight line is summing to 180, so P is going to be 45. Now once we get P, we can find R, because R plus P is 180, so R is going to be 180 minus 45, which is 135. And then 70 plus Q is 180, and so Q is equal to 180 minus 70, which is 110. And the reasons for all of these are opposite angles in a cyclic quad sum to 180. So we can just replace them and put them in the diagram right here. Now let's look at an extension of the cyclic quadrilateral theorem. Now, if we have two tangents drawn from a single external point and they are equal in length, two tangents and two radii, they will form a cyclic quadrilateral. So we just gave two important pieces of information right there. Two tangents drawn from a single external point, they're going to be equal in length to the point of contact with the circle, that is. So notice on the diagram, we notice that we see a cyclic quadrilateral being formed because angle x plus y is 180, and we see two 90 degrees angle. Why is that? Because we already know from theorem number 3 that angle between tangent and radius is 90 degrees. So we already know angle between tangent and radius is 90. So 90 and the 90 is 180. X plus y is also 180. And we'll see that from the point, that black point, up until the point of tangency, those two are equal in length. And the two radii are also equal in length. So we must bear that in mind in order to do these types of questions. And so let's look at an example right here. It says AC and BC are tangents to the circle with the center being O. Find the size of angle X. Now we know that 4x plus x is 180 because two tangents AC and BC and two radii OA and OB form a cyclic quadrilateral. So 5x is 180. So we divide both sides by 5 and x is 36 degrees. So x is 36. Easy. Now theorem number 6 is known as the alternate segment theorem. Alright? And so the alternate segment theorem, as displayed on the diagram right here, the angle between a tangent and a chord through the point of contact is equal to the angle subtended by that chord in the alternate segment. So notice in fade pink, we see angle y right there, angle between the tangent and the chord. Angle between the tangent and the chord, those two angles right there, y's are equal. And those two angles right there, the x's are equal. Alright? So look at this picture right here. Find the missing angles below, given reasons in each case, using this alternate segment theorem. Alright, so as we can see straight away, the angle between the tangent and the chord for the alternate segment, in this case x, so x would be 45. Alright, and also y is going to be 60 degrees because angle between tangent and chord is equal to angle formed by that chord in the alternate segment. Alright, and so once we get x and y, we then know that y plus z plus 45 is 180. So z is 180 minus y minus 45. So z is going to be 75 degrees because angles on a straight line sum to 180. Nice. Now, let's try a more intense question here. So pause the video and attempt this question. It says PQRS is a cyclic quadrilateral, APB is a tangent to the circle at P, PQ is parallel to SR, angle SPB is 35 degrees, and angle PSQ is 80 degrees. Now we need to find angle A and B on the diagram. So pause and attempt. Now as we pause and attempt, right, straight away what we're going to do is let's put that angle right there, theta. We'll put an angle on the diagram and we'll call it theta. Now angle between tangent and the chord is equal to angle formed by the chord in the next segment. Alright, and so theta is 35 degrees using the alternate segment theorem. Now once we get theta to be 35 degrees, angle QPS is going to be 180 minus 80 plus 35, which is 65. That's because angles in a triangle sum to 180. So we can put 65 right there on the diagram. Once we get that angle to be 65, we know that A plus 65 is 180 because we realize that QRSP is a cyclic quadrilateral, and so angle A is 115 degrees. Once we get angle A is 115 degrees, we know that 65 plus 80, and we're going to call that angle there alpha. So 65 plus 80 plus alpha is 180 degrees. And so if we transpose for alpha, alpha is going to be 35 degrees. That's because co-interior angles sum to 180. So remember we did look at co-interior angles. Notice that QP and RS are parallel to each other. And then we have the line PS, which is the transversal line in this case. And so that allows us to use co-interior angles summing to 180. Or you could have done it this way and realize that those two angles are 35 by using Z angles. You could have done it that way as well. So now to find angle B is 80 degrees by using Z angles, alternate angle theorem. So you can always bear those theorem in mind when you're doing circle theorem questions. Alright, so angle A, just to summarize, is 115 degrees and angle B is 80 degrees. Now, having done all of the circle theorems that we need to know, we're going to look at a couple exam style questions so we feel confident. So I want you to pause the video and attempt these questions. These are exam style questions now. So this question says PTR is a tangent line to the circle at T. Find angles SUT, SOT, OTS, and OST. Alright, I guaranteed I've paused and attempted, so let's go through. Now we know that angle OTS plus 65 equal 90 because angle between a radius and a tangent is 90. So angle OTS is going to be 90 minus 65, which is 25 degrees. Once we get the angle right there inside the triangle to be 25, we then know that the other angle in the triangle will also be 25 at angle S because it's going to be an isosceles triangle. Hey! And so angle SOT is 180 minus 2 times 25, which is 130. That's because angles in a triangle sum to 180. So we can put the 130 on the diagram. Then angle SUT is going to be a half of 130, which is 65 degrees, because angle at the center is twice the angle at the circumference. Okay, and put on the 65. So that question was very easy. So let's attempt this one right here. PR and PQ are tangents to the circle. Find the missing angles, giving reason for your answer. We need to find Z, W, X, and Y. Pause the video and attempt. Alright, now let's do this question right here. Now we know that W plus 110 plus 48 is equal to 180 degrees, because opposite angles in a cyclic quad sum to 180. Alright, so notice that all four vertices of the quadrilateral in the circle are touching the circumference, so it's a cyclic quad. So that will give us that W is 180 minus 158, which is 32. So W is 32 degrees, so we can put that there. Once we get W, then that allows us to get the angle at U. So the angle at U that we put on the diagram in red is also 32, because it's going to be isosceles triangle. And so since the angle at U is 32 degrees, we can find the angle at O. So the angle at O is going to be 180 minus 32, which is 116 degrees. And that is the angle at the center. Now, Z is the angle at the circumference, and angle at the circumference is a half the angle at the center. So Z is a half of 116, which is 58 degrees. That's because angle at the center is twice the size of the angle at the circumference. So we can replace those on the diagram now. Put the 32 in white, put the 58 degrees in white. Now we need to find the other angles. Now, 116 plus y is 180, because two radii and two tangents form a cyclic quadrilateral. And so 180 minus 116 is 64. So angle y is 64 degrees. We can then put that on the diagram as well. Now we need to find angle x. To find angle x now, we know that 32 plus x is 90. And so x is 90 minus 32, which is 58 degrees. That's because angle between a tangent and a radius is 90 degrees. Or you could have looked at it and saw that angle between tangent and a chord is equal to angle subtended by the chord in the alternate segment. So you see the 58 degrees in white? Right there, we can say x is 58 using alternate angle theorem. So we can replace those now with 58 degrees. And that completes the diagram right there, and that completes the question.